A very warm welcome to lesson 8 of my Surpac tutorial series. My name is Kobe, and in today's lesson we will learn compositing. If you take a look at the navigator pane in my previous work directory database, I have created a new folder called compositing and I have set it as my work directory. I have imported these files which will be used for today's studies. Okay, so let's move on. Before performing geostatistical analysis of data in a drill hole database, it is often required to start with compositing a sample value within a given geological zone. So the question that may arise may be, what is compositing, or what are composites? Composites are divisions of the drill holes to a particular sample length, calculating the grade for samples using the actual sample values. So when you create composite in Surpac, you're kind of creating points for each sample value and storing it as the grade for that composite interval that will be specified. A string file will therefore be generated, and this string file will be used for statistical studies such as creating a histogram to determine outliers of your dataset as well as bimodalism. Again, you can use the string file for geostatistical analysis such as variogram modeling and block estimations. Alright, so how do we go about creating a composite in Surpac? Before you proceed, make sure your database is connected. As you can see mine here in the status area. Then you head over to database, composite, downhole. There are several ways by which one can create composite, but we want to create composite down the hole of each drill hole, that is from the collar to the bottom of the drill hole, because composite samples are collected from drill holes at specific intervals. Alright, so we will go by the downhole method. I'll click on that and we are presented with the composite downhole window. Okay, I will explain whatever text that is indicated on this form. I'll begin with define the string file to create. Location. Here you are supposed to enter a name for the resultant composite file which will be created. ID number. Whatever number you enter here will be attached to the location. Okay, so for example, if I enter a name for the location as composite and I enter an ID number of 5, the resultant composite file will have a name composite 5. Good. String number, the default here is 1, but you can enter any number to suit your preference, but based on the minimum percent of samples to be included. Other strings may be created in addition to the nominated string here. Composite length. Depending on the drilling program or the drilling project, at what intervals along the drill holes are composite samples collected and taken to the laboratory for assays to be reported. In choosing the composite length, you would want to consider the opinion of a geostatistical consultant to determine the optimal composite length for the dataset. Determine composite length by, I'll click the drop down here so we see the list we have. We have first length and best fit. First length method will produce samples of equal length, except when the sample length is not sufficient to create a full length composite. And the best fit method will create composites of variable length, but the composite length will be as close as possible to the nominated composite length. So note the difference. First length produces composite samples of equal length. Best fit produces composite samples of variable length. Good. Then I come to minimum percent of samples to be included. The default value here is 75. What this means is that 75% of the specified composite length will be used in calculating the composite value. Alright, then I come here to define the zone selection method. As you can see, there are 3 options from which one can select: no selection, multiple zones, zone from 2. If you select no selection, composites will be created for all the drill holes without any constraint. That is from the top of the drill hole to the end of hole. If you select multiple zones, you'll be able to create composite for a particular geological zone. You kind of constrain your composite. For instance, you can choose to create composite for your ore zone or a particular rock type. Zone from 2. When you select this option, you'll be able to create composite from the top or bottom of one geological zone to the top or bottom of another geological zone. Alright, Dilute negative samples. When you are compositing in Surpac, negative samples are inferred or assumed as missing samples and can be treated in the compositing process in one of two ways. The first is when this box is checked, negative samples will be assigned a value of 0 and it will be included in the composite, and this will decrease or dilute the composite value. If the box is unchecked, the missing sample will be ignored and will have no effect on the composite value. Okay, table name. From what table in your database do you want to create composites? I'll click the drop down. Here we are provided with a list of interval tables that we have in our database, meaning whatever table you select or nominate here should be an interval table. It should have a depth from and a depth to field. Good. Then I come down here to fields to be composited. Field name. From what field in your table do you want to create composite for? Again, you have to take notice when you are filling or selecting this field. The field selected here should contain numeric data. While the table should be an interval table, the field should contain numeric data. Good. Then I come over here to optional weighting fields. Field name. You will enter the name of the field, which are to be used for weighting the grade or quality of samples, in addition to the length weighting. Usually, this field should be or should comprise of specific gravity or sample recovery. Okay, then I come to default. The value here has been preset as 1, but you can enter any value here to suit your preference. Whatever value you enter here will be used as the weight if a particular sample has no weighting field. That is, in your database, if a sample has 0 or negative value, the number entered here will be assigned to that particular sample. Include limit. The value entered here is something like a cutoff or a boundary value for the weighting field. If the weighting field for a composite is less than the value entered here, then that composite will be assigned to the next string number, in this case string 2, because we have already nominated string 1. Beautiful. So now that we are familiar and conversant with all these tests, we will go ahead and fill it with values. We will first create composite using the no selection method. Afterwards, we will come and create composite using the multiple zone method. We will constrain our composite. Okay, so because I want to create composite for all the drill holes using the no selection method, I will give it a name, composite drill holes, for all the drill holes. I will leave the ID field blank. The string number will maintain the default string 1. Then composite length. In my assay table from my database, samples were collected at 1.5 meter intervals apart. So that is what will be entered in the composite length field. Okay, so I'll enter 1.5. Then I'll go by the first length method because I want to create composites of equal length. Minimum percent of samples to be included, I'll maintain the default 75, meaning 75% of 1.5 will be used in calculating the composite value. We can do the calculation ourselves and see. Let me search for my calculator. Okay, so 75% of 1.5, 0.75 multiplied by 1.5. This is equal to 1.125, meaning sample which has length greater than 1.125, greater than or equal to 1.125 will be assigned string 1. Those which are less than 1.125 will be assigned the next string number, in this case string 2, because we have assigned string 1 already to those which will be greater or equal to 1.125. Okay. Then I will select the no selection method because we want to create composite for all the drill holes. I want dilute negative samples. Table. From which table do I want to create the composite? Of course, this is going to be the assay table because the assay holds my gold values. I will select assay. Then the fields to be composited, full name is going to be the gold. Then the optional weighting fields. We do not have sample recovery or specific gravity field, so we will leave this field blanked or unfilled. Then I'll click apply. Define query constraints. We do not want to apply constraint to our data. I'll click apply. And as you can see, we are presented with some statistical values, minimum and maximum value. We have the standard deviation, variance, and so on and so forth. Okay, so let's bring our file, composite drill holes. This is it. I'll click and drag. Okay, as you can see, we are seeing two strings here. We have a white string, which is the string 1. This blue string is string 2. You can inquire that. Segment properties. The blue one is string 2. Okay, and the white one is string 1, as you can see here. Good. So the string 2 that you are seeing here is the samples which has their length less than or equal to the 1.125. That is the 75% of 1.5. And the string 1 is the sample length which is greater than or equal to 1.125. Okay, so the string 1 are those which passed the 75%. We can view the content of this file by clicking on it, right click, select edit. So when you create a composite, this will be the content. The first line here will represent the header. The second line will represent the access record. The third line will represent the string data. So this is the string number. This is the Y coordinate, that is the northern. The S coordinate, the eastern. The Z coordinate, the elevation or reduced level. And we have the good values. The first description field, this is the good values. Remember, it was created, composites are created from sample values. Okay. The second description field is the whole ID. The third description field is the depth from. The fourth description field is the depth to. The fifth description field is empty, as indicated by the 2 commas here. The sixth description field is the interval, that is from 0 to 1.5. The interval is 1.5. From 1.5 to 3, the interval is 1.5. And this was the composite length that we specified. Okay, if you scroll down, you will see that there are also string 2s in there, as you can see, because in graphics we have string 1 and string 2. This one. Okay, so we created a composite for all the drill holes. I can display the drill holes from no particular table, and we will see that. We see the composite were created from the color of the drill hole to the bottom or to the end of hole. Let me hide the strings for the composite, display its points as well as their good values. Okay, so this is it. These are the composite values that were calculated from the composite, from the sample values. Okay, so these are the composite, the grades for each drill hole based on the 75% of minimum samples. Okay, so now we are going to create composite using the multiple zone, meaning we are going to create composite for a particular zone. And which zone do we want to create composite for? We would want to create composite for the all zone. This is our all domain. You know, this all is defining domain of the area. So whatever estimation that we will make will be based on the all, because this is defining the domain of the geological area. Okay, so we will constrain our composite with the drill holes. Remember, we created an intersection which was between the drill holes and the all envelope. So the strings you are seeing inside there are that part of the drill holes which intersected the all DTM. Okay, so we will create a composite constrained by that part of the drill hole interval, and we will compare the difference. Go to database, composite, downhole. And this time, because I'm creating the composite constrained by the all, I will give it a name, composite all. The same parameters, but this time around I'll select multiple zones. I'll click that. I won't dilute negative samples. I want it to be excluded. The table name still remains assay. Field name, good values. No optional weighting fields apply. And here on this window, we are to define the geology zones. From which zone that do we want to create composite for? The part where we want to composite. We are constraining our composite. Okay. So the table will be intersection because we want to create composite for that part of the drill holes which intersected the ore. And the field is going to be the ore zone field. And the specification which we stated, the code, when we were performing analysis between the ore DTM and the drill holes, the code we gave it was 8. You will enter that here. And the intercept from 1 to 999 here, you specify a large interval number so that it will cater for everything. I'll click apply. No constraint to be applied to the compositing. Apply. Okay, again we are presented with some statistical values here. Good. So this is the string. As you can see, the string 2, the blue one here, refers to those samples which had their length less than the 1.125 or the 75% of 1.5. And the string 1 here, the white one, refers to those which had sample length greater than or equal to the 75%. Okay. So if I should display the drill holes, you realize that this isn't from the color of the drill to the bottom. It is constrained that part of the drill holes which intersected the ore. So I can bring my ore DTM and we'll verify that. You see, it is constrained within the ore DTM. Let me display the points and the good values so we have a clearer picture of that. Now display the points. So this is the composite of the part of the drill holes that intersected the ore. Okay, so we have created a composite for that part of each drill hole which fall inside the ore. Okay, let me display the good values. Okay, beautiful. So these are the good values of that part of the drill holes which intersected the ore DTM. Okay, there is another way of getting points which are inside the ore DTM. Remember, this is a method using the multiple zone. We constrained the composite using the part of the drill holes which intersected the ore DTM. Okay, so we can go about it by using a different method. Remember, if I should bring my composite file, the composite for all the drill holes, and bring my ore domain DTM, you see that one goes beyond the ore DTM. There is another way of getting points, the good values, points which fall inside the ore DTM without using the multiple zone compositing method. So with that method, we will only extract points of the composite which fall inside the ore DTM. It will be similar to the multiple zone method. Okay, so let's do that quickly. You go to solid tools, point inside and outside a solid. I'll click on that and we will be presented with this window. The 3DM, that is the three-dimensional model or the solid. In this case, the ore DTM is what we will select. So I will go here into my work directory and I'll select ore domain 1 DTM. Then the string file to be processed. The string file that we want to extract its points is the composite file. We want to know which points of this composite fall inside the ore. So we will select that string file, composite of all the drill holes. Okay. Then define the output file to be created, file name, the name that you want to give to the resultant, the points which will be extracted in the ore DTM. I would want to give it a name, composite, okay, let's say composite inside. Then select data. We want to select points which are inside the DTM, not outside. Operations, select or tag. If you select tag, you see the description field becomes active. it will tag the description fields of the composite drill holes to the resultant, the composite inside. We do not want to do that. We only want to select points inside of the ODTM. So we will use select, not tag, and I'll click apply. Okay, so it says 311 points. Let's go into our work directory. I will exit graphics and bring my file composite inside. So this is it. If I should bring my all domain 1 DTM, you see it's also falling inside. Let me hide the all DTM. If you notice, this one has no string 2 because we did not go by the compositing method where we will specify 75% of the composite interval 1.5. In this case, we only extracted the points of the composite which fell inside the all domain. Okay, that is why you are not seeing any string 2 to show which sample length passed the 75% and those which didn't pass. All right, so I can bring the composite all and we'll compare the two. If I should delete this layer, you see, if I should hide the composite all, you realize that that is the one which contains the blue string 2 because we composited that using the multiple zone method. Okay, so we can view the content for both files, the composite inside and the composite all. Okay, so these are the two files. Remember, the coordinates are the same. The gold value 0.36, 0.36. The same interval 19.5 to 21, 19.5 to 21. The interval is also 1.5. So as you can see, this is the header, composite inside, and the composite all. This method will create composite inside the ODTM. But we created this one using the composite multiple zone. We constrained our composite, and this one we extracted points which fell inside the ODTM. Okay, so in using your composite for block estimations, you go for the file which has the many points. Okay, we can verify that composite all, this was the one created using the multiple zone. We can inquire the number of points we have here. Inquire segment properties. I'll click on this. And as you can see, we have 307 points for string 1. Can also go and determine for string 2. String 2, we have 5 points. So 307 plus 5 points. In all, we will have 311 points. Good. Again, I will exit graphics and inquire for the composite inside. Segment properties, I'll touch this and we have 311 points. Perfect. So meaning that both files, the composite inside and composite all, will have the same points, except that the composite all, which was created using the multiple zone, will have a string 2. Okay, in using the composite file to estimate your block, you can use both string 1 and string 2s. In either case, because we have extracted the points of the composite which fell inside the ODTM, we can also use this file. Okay, so this is it. This string file will be used to perform statistical analysis such as creating histogram to determine if we have outliers or a bimodalism in our data set. It will also be used to estimate the block. Okay, so that will be it for compositing. In the next lesson, we will learn basic statistics. Please don't forget to subscribe to my channel. Thanks for watching and catch you in the next lesson.